Welcome everyone to this 1010 webinar from basics to brilliance, master the art of prompt engineering. We've got some exciting content to share and some demos that George and James are going to get into very soon. So I'll hand over to them in a moment for the main event. But before we do, for those that maybe are new to joining us on these webinars and maybe don't know who 1010 are, I'm just going to do a very quick introduction. So we're a specialist technology consultant dedicated to tackling the UK's productivity challenges through a quality first AI native approach to digital transformation. We partner with organizations to transform efficiency, agility, speed, and growth by delivering cutting edge solutions across AI centric cloud data, quality engineering, and agentic automation. Our core philosophy is ensure confidence and successful adoption by embedded quality at every phase. What sets 1010 apart is our commitment to long-term capability. We operate an award-winning technology academy, developing and deploying next-generation AI-enabled tech talent. By combining our experienced consultants with our academy graduates, we help businesses modernize infrastructure, enhance software quality, and unlock the full potential of AI for a sustained competitive advantage. So for those that maybe have been on one of our other webinars, you'll see that this is a series of webinars that we've been doing that have all been focused around AI. We've done we had an initial webinar focusing on Playwright MCP. Our last webinar was focused more on leadership and leading through the AI revolution. That was with Ash. And in this session, we're going to get under the covers of prompt engineering with George and James. And I'm going to hand over to George in the first instance now to introduce himself, and then over to James. So George, over to you.
Yeah, perfect. Thanks to you. So for those who don't know me, so I'm George, one of the technical principal consultants at 1010. It's got a good experience in automation, performance, and DevOps. We're kind of more recently kind of focusing on supporting organizations with their kind of journey and integration of kind of AI services. So with that, we're focusing on kind of proof of concept, early stages, and AI kind of in test, but also thinking about kind of testing it, Gen AI and traditional ML kind of applications. So that's myself, and I'll pass over to James.
Hi, everyone. I'm James Stubbs. My background has been in consulting. Recently was working for Celonis for a long time as a staff engineer, and I've joined 1010 around 7-8 months ago. My focus here is on test automation, but also recently been helping to integrate a lot of our services and our own internal AI platforms, working with George on that. So we've been obviously looking at system level prompting, and it's interesting to get to share some of that with you today.
Perfect.
I'll be
So
doing...
James, sorry, James, just before we jump into that, one thing I did forget to say is if people do have any questions throughout, please drop them in the Q&A box and we will pick them up at the end. Sorry, I just needed to make that point so that people understand. Cheers.
Yeah, thanks, Stu. So we'll be diving into it now. We'll be covering, we're going from brilliance, basics to brilliance. So I'll be covering a lot of the basics today, talking about some of the foundations of prompt engineering. George will be talking about some of the more interesting applications of it as well. And we'll show you some demos and things, and hopefully you'll have something to take away from it at the end. So let's get into it. So this is what we'll be looking at today. We'll be starting with the introduction. I'll try and set the stage for prompt engineering, tell you what it's all about, before taking you on to a bit of an introduction to basic prompting. And we'll talk then a bit more about advanced tooling, MCP tool and tool calling, and testing agents. And like I said, George will be taking you through those last three sections. So why do we do prompt engineering? Well, the main thing is LLMs are they're built to be creative and probabilistic, and left to their own devices. If we ask the same question to a large language model twice, we expect to get two different answers. And this is essentially a feature of LLMs. They're trying to predict things, but also they're trying to come up with creative solutions. It's a feature, but businesses can't operate in this way, right? We need things to be reliable. We need things to be repetitive. We need structured outputs that we can use for our business processes. So part of prompt engineering is trying to create order from that probabilistic chaos. and trying to create deterministic outputs from that is what we're doing. So we're using specific instructions. We're using context, which may be related to your business, formatting rules to create formatted probabilistic outputs. So we want to give ourselves deterministic, reliable results, and that's what we're trying to achieve with prompt engineering. So, what are the foundations of prompt engineering? So, the core prompt in the middle, this is your primary instruction. So this is what you want the AI to do, but on its own, this isn't enough. If we give an instruction to an AI, to an LLM, it's going to give us its most likely correct answer based on the foundation of knowledge that it knows, based on everything else, but it doesn't relate directly to you or your business. So we need to give it more than that. Now, the first thing we're going to talk about is role-based personas. So if I'm going to be creating something for test purpose, I want to give my AI a test-based persona. It might be that it's a senior quality engineer to give it more of an idea of where I want the knowledge to be pulled from when I'm creating that prompt. And then it restricts the AI's knowledge base to that specific expert, immediately improving the quality of the output. Next, the chain of thought. We'll talk a bit about this. So this is the key to complexity. So we're telling the AI to show it's working out. We're forcing the model to follow a step-by-step reasoning process, and these are obviously better in models that are more focused on reasoning. But we want to know how it's working things out, and we want it to take its time, work step by step, and that leads to more accurate and reliable results for us. We use few-shot prompting, and this is how we teach by examples. So if we provide examples to our model, it's going to know what good looks like. We're going to say, this is something I prepared. This is something that I've done already that I want to replicate many times. So doing that will provide it with an idea of like I say, what good looks like, and give it an idea of the desired input and output. So we set a clear standard for the AI to follow, which is particularly useful for things like generating structured test data. And then we have negative prompting. So obviously we want to constrain our LLMs. We want to make sure that the guardrails are in place. So beyond additional guardrails, such as not going beyond certain token limits, things like that, we also want to constrain our prompts. So it's not going to go beyond the bounds of what we expect. So this is less common than the others, which would be really important, but you may have crucial negative prompts that you need to put in. So we want to create exclusions that actually add to our foundation layer. And that's going to ensure that the output is exactly what the business requires, repeatable, reliable, and correctly formatted. So kind of going the same thing again, but a bit more detail. So, if there's one mindset shift that I want everyone to take away from this, it's stop treating the AI like a search engine and start treating it more like a very capable but very literal junior engineer who's going to take on everything that you tell them and give you the exact result of that. So when you ask Google a question, you type in a few keywords. But when you assign a project to a colleague, you give them a brief, you give them a set of requirements, right? So this 5-part anatomy is the blueprint for writing a flawless brief. And it's how we force that probabilistic machine to act predictably. So step 1, the role. So this is when you hire an expert. It's when you tell the AI who it is. And if you don't do that, it acts like an average internet user. It's absorbed the content of the internet and it's going to spit out the average result. If you tell it who it is, we want to force it to adopt the vocabulary and priorities of a senior specialist in your business area. Then you've got number 2, the task. So this is the specific job that we want the AI to carry out. And we have to stop using passive words like help me with this, and start using precise action verbs, things like generate, critique, extract, analyze. These keywords will really help it to know what it's actually trying to do. Then you've got number 3, the context. So the AI doesn't know your business at all, right? It knows too much, but it also isn't very focused. How do we bring it in line and try and funnel that compute power into something very focused? Well, this is where you paste your raw material. It could be your Jira tickets, your API documentation, your JSON payloads. We need it to work for us and we need it to work within our own reality and business context, and that's where we do it. Then you've got step 4, constraints. So obviously AI models, they're people pleasers, they love to over deliver. They'll always tell you you're right and that everything you've done is great. But constraints are the guardrails that we put in place. It's where we state, what not to do. Don't test the back end. No conversational filter. Be very clear if you think this is wrong. We need to sometimes remove some of that fluff if we actually want to get business value out of these things. And a lot of the AIs are written to be overly friendly. Maybe we just want results. This would be where we would tell it that. And then you've got number 5 again, the format, the last pillar in this puzzle. So don't let the AI decide how to present that data. We need to tell it exactly what we need. Maybe we need a CSV output. Maybe we need a JSON array, Gherkin syntax. You never have to manually reformat it again once you've set it, right? So we can actually put that into our prompt, and we want to basically get the output that we're going to use. This is particularly important if we're doing things like business flows where we're expecting a specific output at the end. We want the AI to be involved, and we want the output to be correct. Now, if you're just asking a quick question, you don't need all 5 of these things. I mean, maybe you just might need to, you might need to give it a bit of extra context. But if you're building a prompt that you'll use repeatedly for testing workflows or building an automation process, then these 5 components are all non-negotiable. So again, how do we start doing that? How do we start building those things into our prompt? I mean, to start prompt engineering, the first thing we need to know is what we want to achieve, really. The most important thing is understanding for ourselves what we're actually trying to do. This is potentially the most important and useful part of a prompt, ensuring that the requirements are clear. We don't do anything in software engineering without having clear requirements. We can't expect the LLMs to provide us with solid outputs without strong requirements. So first of all, we really need to know ourselves what we're trying to achieve. And if we don't know what we're trying to achieve, we can't exactly expect the results to be great. Next, we can do all the other things I've just mentioned. We can add the context. That could be files that will help us. Many LLMs will allow you to, if you use things like Google Workspace, Gemini, you can add sort of 10 files, which will help it to build a context around your business area. Maybe you're using something like Notebook LM, and you've got a whole sort of Google Drive with a bunch of files there that you're using to reference. This helps it to build a picture of your business and actually helps it to be more grounded in reality. And that's what we're trying to do. And then obviously we can apply our role-based persona, our guardrails, add some examples, output, and then we have ourselves a well-rounded prompt that we can actually use in reality. So let's talk about the persona a bit further. So if you've ever been asked to write AI test cases and thought, well, this is incredibly basic and obvious, then this slide is exactly why that happened. So large language models are trained on the entire internet, and if you don't tell the AI who it is, it defaults to an average internet user. And the average person on the internet doesn't know how to properly test an enterprise software product. So you end up with a highly eager, very generic assistant who's actually not very helpful. So to get professional results, we assign a professional persona by simply stating your prompt, to act as you're effectively building a fence around the AI's knowledge base. You're telling it, ignore the average user, only give me the vocabulary, the priorities, and the paranoia of this specific expert. So let's take an example here. So you've got a user login page. If I give the AI 4 different personas, but I ask it to test the same feature, let's just say my prompt was test this feature, but we're going to add the persona, then the tool set's going to essentially change completely. So if I say, if I say as a security penetration tester, the AI stops caring about the login button, whether it's blue or not, and only cares about breaking in. It instantly pivots to SQL injections, brute force lockouts, session hijacking. Whereas if I were to look for an accessibility expert, then the AI's worldview shifts and then it's checking for screen readers. It's trying to understand error messages. If it can navigate the form using the keys only or using tab. Performance QA, again, it's going to look at things like what happens when 10,000 users try and log in at the same time. If I say a UAT tester, the AI puts on the hat of a real frustrated human and it tries to check if the forgot password flow makes sense. So this is how we're going to think about the persona. It's going to completely change what the AI will try to do based on who it thinks it is. So don't just say act as a tester. give it some seniority, this really will help it. So if you say you're a world-class security engineer with 15 years of experience, I mean, it sounds silly. It sounds like I don't know why I would need to flatter a machine, but actually you're forcing it to use a higher quality data set. It's going to only use those higher quality training references. Reference the higher quality training data and cut out the beginner level fluff, so it's not going to think it's a junior developer. It will actually pull from better data. This is just part of the way it works. So let's talk a little bit about the task part of it. So this is really important. We've hired our expert, we've set the role, now we have to tell it what to do. Well, the task itself is where most people get a bit lazy. They treat AI like a search engine, use words like, hey, can you look at this code, or can you help me with this Jira ticket? When you say help me, the AI has to guess what help looks like. Does it mean to summarize it? Does it mean to fix it? Does it mean to mock it? If it guesses wrong, you've lost your determinism. The secret to the task is swapping out passive verbs for highly precise action verbs. So don't say look at, say analyze, critique, compare. Don't say tell me about it, say extract or summarize. So treat the AI like a literal machine that needs a specific command to execute, because although it has all that fluff, really, it's just computation underneath. Now let's talk about this example. So imagine we feed the AI a terrible one-sentence Jira ticket, something like users need to be able to upload a profile picture. We're keeping our senior QA role again, but if I tell the AI to critique the ticket, it acts as a sounding board. It tells me if I forgot to define the max file size, supported file types. If I tell it to generate, it instantly builds my test suite. If I tell it to translate, it's going to then convert text to plain English, that plain English into Gherkin syntax for the automation framework. If I tell it to draft, it's going to write an email to my product manager pointing out the flaws in the requirements. So the input didn't change. Again, this is about changing that one aspect of the prompt, and this is the role. The role is the same, but we're swapping the verbiage and we're changing the task, and we've turned the AI into an auditor, test generator, a translator, and a secretary. All of these things just by changing that one element of the prompt. Now we're talking about the context a bit. So this is the step that cures AI of those hallucinations. If you take away nothing else today, remember this: treat the AI like a brilliant reasoning engine, not a factual knowledge base about your company. So if you ask a mechanic to fix your car, but you don't actually bring the car to the garage, they're going to guess what's wrong with it based on what they've seen before, right? Now, context is actually bringing that car to the garage, opening the hood, letting them take a proper look at it. So in software testing, context, is the raw material we have available to us. It's our acceptance criteria, it's our Swagger API documentation, JSON payloads, stack traces, server logs, code base. We can take that data and we can paste raw data directly into the prompt, and it gains the knowledge of that additional information. Or we can do something like use Copilot and have the LLM, give it access to our code, let it run stuff using MCPs. And it's a longer, it's no longer just guessing based on the probability. So it will actually have more of an idea about what's going on under the hood in your code base, and it will be more useful to us. So hallucination versus precision. What we have here is an example about processing a refund. So if I ask AI to write tests for a refund endpoint on my website, it's going to hallucinate based on the most common internet data. So it will give me tests for Visa, MasterCard, 3 to 5 business day delays. It'll make assumptions, just as you or I might make assumptions if we didn't have the full picture. We would probably ask the right questions, right? We find out about a requirement like that. We want to know the details, but without the right framework behind it, LLMs won't do that. They will just blindly assume that they've got all the information and that they're going to guess the rest. They make probabilistic assumptions based on the training data they've received. But what if my company processes crypto transactions? Well, by simply pasting a snippet of my JSON payload then into the prompt as a context, the AI feels like a wallet ID and gas fee, and it will drop the credit card tests and it will generate highly specific boundary tests for blockchain timeouts and invalid wallet addresses. So I don't have to explain every part of how the system works. If I'm providing the context, the AI will be able to work out and fill in those gaps. I just have to show as much data as I can in order to achieve that. So we've already gone through hiring the expert, giving them a task, handing them more context about it. Now we have to rein them in a bit. So if you've used AI before and got a massive wall of text that covers way more than you actually asked for, it's because you didn't use enough constraints. So AI models are designed to be extremely helpful, which means that they tend to over deliver a lot of the time. And constraints are the negative space of the prompt. So it's arguably more important to tell the AI what not to do than what to do. So if you're testing a feature, you need to ruthlessly defend the scope of your test. And this is where oftentimes we'll try and rein in the AI by restricting it. So we build those guardrails. Let's look at a simple search bar. If I just ask for test cases, the AI wants to show off it's going to give me SQL injection tests, database indexing tests, API latency tests. But what if I'm just the front end tester? I don't care about the database right now. I just want to know if the search box overlaps with the logo on an iPhone. By adding a strict constraint, literally typing do not include security or backend tests, I force the AI to stay in its lane. I also added do not include any introductory text because as engineers, we don't need the AI to say, sure, I'm happy to help with every time we run a prompt, right? We just want the data. We just want to get to the output. So we can ask it not to include things, and it will make our lives easier. Okay, and then the final pillar of this well, we're going to put together the format now. Sorry. So this brings us to the final piece, and it's the format. It's the last mile of determinism. So if you've done everything else right, you've let the AI decide how to present the information, you're still essentially doing the manual labor. AI models, they love to chat, right? They want to say, here are your test cases, and end with, let me know if you need anything else. If you're a QA engineer, you don't want a pen pal, right? You want data that fits into your existing tool chain. If you're running workflow processes, you need output data that can move into the next step. And that doesn't necessarily need to be wrapped in, fluff. If you have to spend 10 minutes reformatting every answer that comes through, then it's going to be a waste of time and you're not actually saving time at all. So how do we do that? Well, it's very easy. We just, instead of letting AI write a messy bulleted list in this example, we explicitly command it to output a JSON array. We even tell it the exact keys we want to we want test IDs, we want descriptions. So we add a final constraint telling it to shut off its personality and only output that code. And why does it matter? Well, because now you can take the exact output, you can save it as a file, you can bulk import it directly into your test management tool, or feed it straight into your automation framework. So you've turned a chatbot into a pipeline utility now. So all of that stuff, goes together, and we've got a scenario here. Let's say we've got a new promo code input on our website. The field accepts alphanumeric codes up to 10 characters long, right? So if we say write some tests for the new promo code on a checkout page, it's going to go through, it's going to think about all of the promo code boxes it's seen on the internet in the past. It's going to try and come up with the most likely result based on all of those promo code inputs, and then it's going to try and generate tests based on that. So it will give you, some happy path cases. It will look for invalid code cases. It will look for expired code cases, but it's not going to be relevant to your site. It will be the best guess scenario. So if we give it a proper prompt, act as a senior QA automation engineer, generate a comprehensive list of boundary and negative test scenarios for the promo code input field. We provide some context around alphanumeric codes up to 10 characters. We provide constraints that we're focusing strictly on negative testing, boundary values, so basic security inputs. We're not including a happy path scenario here. And we're going to output a markdown table with columns for test ID, description. So we know what we're going to get at the end of it. I mean, that's an example of a well-built prompt that will provide us with something useful from this particular use case. And then when we want to scale that up, so obviously we're thinking here about every single time, we're doing this. We've got 10 QA engineers manually typing, act as a senior QA when they're trying to get something out of this, defining the table structures every time they test a feature. You've still got 10 different variations of the output based on slightly different typing or slightly different combinations from those QAs. So how do we stop that? How do we create standardization and stop this sort of tedious, error-prone style of prompting? So we can use something called system instruction. So system instruction is an invisible wrapper around the prompts within your system. It's an overarching set of rules and constraints that govern every single interaction before the user even types a word. So this would be done at the system level, and it changes the AI's default behavior from something like a helpful assistant to a highly specialized tool that you need. So the user prompting becomes much smaller. We don't have to do all of this stuff every time. But if we're creating a system that's essentially a customer service bot, we don't want to have to tell it the same things every time. We don't want every prompt to be bookended with a list of instructions. These instructions come at a lower level, and they're provided to the prompt by the system itself. And then that then handles all the heavy lifting for formatting, personas, constraints at a global level, and we don't have to worry about that so much at a system level. So that's all from my side in terms of slides. I do have a brief demo now, which I'll just show you, which is something, it's a bit different. So we just talked about building prompts based on asking for specific sets of instructions. Now we're going to talk a little bit about prompting with images, image generation. And you do have to build image generation prompts in a slightly different way. So let me just share this. Can you see my screen now?
Yep.
Okay. So I've got an example here which I created for the webinar, and this is going to be helping us to generate some images of teapots. It's quite specific. We want to generate a series of different images of teapots based on the variations that we're going to be providing, but there should be sort of a standardized prompt in there that we're going to be making changes to. So what we have here is a set number of images, which we can obviously change as an input variable. We have an image size, which can be updated. And also we're using here a fast generate model, which I'm using for the sake of the demo. It may not give me the highest quality teapot images, but it will provide me with them in a timely fashion for you to see. Then we've got things like variations. So different styles of images, different materials that we want those teapots to be in. We're looking at different colors, different settings, and some specific details that might relate to those teapots. So how do we actually build a prompt that we're going to engineer to inject those different variations? So what I've got here is the makings of a prompt. A variation style, which would be any of these different styles, image of a beautiful teapot. That should be standard. Every time we want to generate a teapot, this is a teapot generation script. The teapot is made of specific material, different colors, and different settings. Then we've got these additional details which relate specifically to these individual cases. And we're looking for high quality, detailed, professional composition. Now, obviously, this doesn't make us completely secure. We aren't safe from hallucinations. We may see a couple. But what we'll do is we'll run it, we'll let it generate our 4 teapots. And then the second thing we're going to do is our second comparison function, where we're going to generate another few teapots, but these ones instead will have the same style, the same color, the same setting, and same details. The only difference from these will be the materials. Now, if everything's working correctly, these ones should be exactly the same other than the materials of the pots themselves. Now, it's very likely this is not going to be the case. We don't know what the percentage success rate will be here with our teapot creation, but we're going to give it a run and hopefully it should work. So our first prompt is our elegant porcelain white teapot. We have a brushed stainless steel pot. We have a copper-colored warm orange brown patina pot. And we have our ceramic yellow pot with polka dots. So let's see what results we actually got. Well, that doesn't look like a teapot. Now we know we need to fix our prompt. I mean, actually, I'm quite surprised by how far this has gone, but there's our stainless steel teapot. So we know that there's elements of our prompt that are correct, but obviously this is what we call a hallucination. Now the third prompt has gone completely off the rails, but this is a beautiful yellow polka dot teapot. So 50%, which isn't great, and it shows us we need to really refine that prompt. Let's look at generating those additional comparison teapots and see if we've got everything there. And I would think that these are more likely to all have worked correctly. We're looking for the same background. Now, how can we make sure that it's a teapot every time? So these have all worked well, except for the background here isn't as generic as the others. And we've asked just for a generic white background. but I think these are all done pretty well. Now, if I take an image like this one, I need to run something like a bit of image validation. So this one here, this obviously didn't work. And I created a second script because I kept getting not teapots and I wanted teapots. So this is a validation script and it's going to go through and check that our image exists, but it's also going to check if it is a teapot or not. Here we go. So amazingly, the same one was not a teapot last time. So I can run the same command. Is this a teapot? Now the LLM is going to go and check that image and say, no, I don't see a teapot in the image. There are other containers like glasses, coffee cups, and coffee machines, but nothing that resembles a teapot. I agree. So we need to refine our prompts, but also we need to inject some layer of validation to make sure that we're not actually coming up with poor results. And if we were to do a big bulk image generation, let's say we want to generate 500 teapot images for our website, we would need some layer of validation to go and check that those are exactly what we expect them to be, because even with prompt engineering, we still get some level of hallucinations, albeit 50% was actually higher than I was expecting there, but there will always be some level of hallucination. So being able to go through, check that the images are correct and validate is also another important part of engineering with AI. But what I'll do now is I'll hand over to George for the next part of the presentation. Thanks.
Thank you, James. So I'll share my screen and hopefully that'll come through successfully. In 1 second. I can confirm that you can see that, James?
Yeah.
Yeah, awesome. Thank you. So hi all. So kind of continue on that kind of trend, that theme. Obviously, you've got the foundations. You've got kind of the ideas of where kind of what you need to do to kind of constructing that prompt, kind of the bits to follow, how to format it and get it going. Now we start thinking about where can you go in and apply that. So obviously in the kind of the room, there's going to be a lot of experience from, well, a wide spectrum of experience in terms of people who are going straight into Claude code and kind of multi-agent kind of flows, to kind of the other end of the spectrum where perhaps just using kind of interacting with Gemini through kind of workspace or kind of ChatGPT, just general chat, just messaging. And there's the other side. So it goes into what else can we do? How can we apply kind of these techniques in kind of different areas? And so we kind of take it up from that kind of one notch further to start thinking about, say, like in project AI, so kind of interacting with AI in your IDE. So I mentioned an example here, probably one hopefully is most common in the room. So kind of GitHub Copilot in VS Code. And then here, what we get to see is kind of some of the advantages where it has a bit more contextual awareness. And it's something that we don't have to inject ourselves, and it's just kind of done kind of natively by the IDE. And it kind of makes kind of improves the effectiveness there. You can also think about kind of leveraging the MD files. So for those who don't know it, these are markdown files. These are plain text files that can be formatted and then kind of previewed with that formatting on top. And it's kind of an excellent way to basically kind of have a kind of summary of text essentially of what the code space is doing. They got custom agents. I've got an example to go through in terms of like how can we apply some of the bits mentioned by James into these agents, kind of including the concept of handoffs, so passing from one agent to another. And then we've got kind of custom prompt templates. So we got kind of mention of gems. I know James mentioned Notebook LM as well. And on the OpenAI side, you've got custom GPTs. So these tools are kind of tools that have been around for quite a while. And what we see is they're not kind of utilized too heavily in industry. Kind of tend to be more the ad hoc, kind of for storytelling, kind of based on more the creative use, as opposed to kind of utilizing for that kind of work, kind of outputs. But so we're going to go delve into a little bit more detail about these gems, these kind of concepts. We're going to go delve into kind of gems, Gemini gems, and why and how we could go about using it. And then we'll go into a bit more detail about the kind of the in-project AI. So thinking about stepping it up, I mentioned gems as an opportunity for you to kind of create essentially a wrapper. So James mentioned kind of bringing it up at scale. So we have started having a system instruction. And what we see here is kind of on the middle on the right images, we have a set of instructions. So the one in the middle, that's just to do with kind of a software testing specialist. It's still quite a bit vague. And one on the right-hand side is from a BA kind of business analyst perspective. But we're still giving it a persona, not a huge amount of detail on what it's doing, but that's the part that's in that light green color. And then we also kind of start indicating what the output formats are looking like. So in this case, we both say, for both of them, we're saying produce kind of your outputs in following BD kind of behavior-driven development conventions like Gherkin, and there is in fact a kind of knowledge base on those gems. And one of the reasons we're bringing up gems is, and of course, reference kind of GPTs as well. They are kind of easy to use, transferable kind of wrappers essentially that can be kind of shared within an organization. So, for example, at 1010, we use Gemini Workspace, and we can create gems that go in and share. And essentially, there's an owner or a series of owners who can go in and set these instructions up, add the knowledge, kind of give the default tools, and that can then be shared. And it's perfect for those who are a bit more comfortable with tools and assisting those who perhaps not as comfortable with going beyond their kind of basic just prompting with kind of Gemini and ChatGPT. So I've got two examples here, and you can probably imagine the test case generation side. So we're going to have it kind of towards the end. We're going to talk about test case generation and the evaluation of it and what leads into it. But essentially, just give a bit of context kind of up front. The one in the middle, this one has basically a series of kind of inputs based upon data that was scraped using Playwright MCP, and the one on the right is based upon kind of requirements, so kind of different perspectives to generate tests. But that'll all come to fruition later. In terms of a bit more ideas of gems, so don't have to be used just in kind of software engineering space. You can get some really quick wins, kind of just sharing it with an organization, within your organization and product team, and it's not just limited to software engineering. So one example of kind of use case is not just kind of having a gem specific to a product or an application or to a kind of knowledge base, but to utilize it to produce kind of RFPs and cell creation, kind of inheriting and pointing it at a large knowledge store, and also be mindful of the gem restrictions. And then that can be kind of owned by, say, delivery, and then shared to kind of the sales kind of or ops to kind of reference and kind of assist them with those elements. So essentially what we're trying to talk about here is use cases of things that can be utilized within the organization to step it up and apply some of that experience into here, add the necessary system prompts, system instruction, so that someone who's not as technical, not as aware, kind of AI aware, can go in and utilize and interact with it and kind of benefit from someone passing out, laying out the time to go in and kind of set it up. But the bit that's probably a bit more exciting, for those a bit more technical, is essentially the MCP side, so the tool calling. So for those who aren't aware, so MCPs is kind of stands for Model Context Protocol, and it's produced by some researchers at Anthropic, and it improved upon a previous kind of implementation called just tool calling. For awareness as well, there's also kind of some researchers in Cloudflare are looking at something called code mode, kind of leverage kind of the inherent TypeScript knowledge, essentially kind of the equivalent of MCP. But foundationally, it's still the same. So it's going to go in and provide that interface between the LLM to allow it to interact with, say, something like an API, a database, or a file store. Now, use cases of this can vary and obviously dependent on the project itself and the restrictions that you have in that project. And we'll go into kind of some examples of how you can manage that within your organization. But kind of some easy kind of quick wins that you can implement is kind of database and state verification MCPs. So you may have kind of generation, so you run an automated test, but you need to interact with a database to confirm that essentially the kind of record or whatever was created correctly. That will then require some SQL knowledge, know how to like obviously utilize database related tools like MySQL Workbench, etc. But what we can do instead is kind of allow or interact with the database through kind of this middleware, the kind of this MCP, who will go in and run queries on our behalf through the LLM. So the LLM will go in and say to the MCP, run this query, hopefully not dropping the database, but obviously you have it kind of restricted by access to say you can only access certain things in a read-only capacity to go in and confirm that data's been set up correctly or the record exists. And it's an easy way to kind of reduce the complexity in kind of in testing teams, where then someone doesn't have to have that kind of SQL knowledge if they can interact with the LLM. But of course, that requires the MCP to exist, the guardrails to be handled alongside it, and the individual to know how to prompt it. Because they may find that if they go in and say, I created a user, find the user record in a database, the LLM is going to try very hard to find all the database, correct, all the schemas, all the tables inside them, and then try to determine which row was created. This is where it goes into, we still need to add it and give it that relevant context and kind of inform what it needs to be doing. And the browser front-end testing MCPs, I'm not going to go into too much detail on that one. Also, we covered, I think Ramesh covered that in a previous webinar. Definitely worth checking out to understand how it can be interacted with. And then similar to the database, obviously MCPs can also do the same for file system MCPs. So we can go in and say, automated test, run, kind of downloaded this file. I want to go in and process it. I can get the automated test to fire off a kind of basic LM command, which go in, pick up the file through an MCP and basically process it. Go in, parse it, understand it, extract contents out, and that can be done through kind of the MCP side. One of the great advantages that I think we kind of, it's a bit of a kind of sleeper advantage, is the MCP allows us to make things a bit more deterministic because we are giving something, okay, essentially an input into it that could be very non-deterministic. And we get an absolute value out of it. So a query runs, but generation of the query would have been non-deterministic, but the output would have been an absolute value. Either it exists or it doesn't. And through chaining of these MCP tools, we can start improving our confidence in terms of what we get back to us. And talking a bit more about around kind of other use cases and examples, log and metric analysis. So some things that are quite kind of time consuming is processing logs. And again, we can set up kind of MCPs to interact with logs, to find it, parse it, and basically run queries. So things like KQL queries or kind of Azure platform, and which can be quite time consuming to produce and verify, but we can go in and assist us on that context. And with the great thing about the MCPs, utilizing agents, it'll start calling upon itself and we can start benefiting from that aspect. But one thing I kind of mention is in case others aren't aware, so what we're seeing now is a bit of a kind of shift in terms of recognition that MCPs obviously kind of exploded over the kind of last year. And what we're seeing now is organizations looking at how can they start leveraging this. So hopefully one thing to take away is kind of the concept of MCP marketplace. And what we're seeing is some organizations are now starting to basically have their own marketplace, a list of approved MCPs and go in and use. These MCPs could be kind of external MCPs. So for example, Playwright MCP, which could be a good one to kind of go in and play around as your first interaction, but also an opportunity to create internal MCPs. One of the advantages of having or kind of supporting organizations in the drive to having their own MCPs or their own kind of MCP marketplace is that it provides a kind of central location of MCPs that have essentially been approved. So they can be updated or managed through an allow list or a private marketplace or kind of restricted to specific registries, kind of thing, and then extra rules on top of it to enforce sandboxing, essentially to make it a bit more secure. Because we do have to be mindful of kind of the MCP that you might find off the street may in fact be kind of sending our data to a place that we don't want it to be sent, or they might not be aware of it, which is a great way why we kind of essentially promote the usage of the MCP marketplace or internal MCPs that have essentially been approved and can known about. And one thing I kind of mention as well is you can create your own MCP. It's relatively trivial to do. And then so you can have set it up and then connect it to kind of your local agents as well. And of course, then commit that code, push it out and share it within the organization. But essentially these kind of custom MCPs, basically wrappers for internal APIs, they'll allow you to kind of connect to services that essentially wouldn't have an MCP. So for example, if you have a test case generator, test data generator, or something that sets up data specifically within your organization, because when you're working for a product that's quite complex data-wise, you could then kind of essentially wrap those APIs in an MCP, and then as part of your test case generation, you can go in and say, oh, I need to set up this data or whatnot. But essentially, you're creating an interface into kind of your internal APIs with MCP. It's going to go into the next slide in a second, but we'll talk about kind of some tips. But one thing I kind of point out to here is in the kind of central, in the middle image, we have essentially kind of list of tools that I can go in and do. We've got name and description. Similar to what James was mentioning around, because it's like making things clear, we do want to make sure that our description is relevant as well, because ultimately the LM is going to go in and find the tools and understand which ones are relevant based upon the description provided and the name provided. So one thing that we do see in terms of the tip is if you're finding it like the LM essentially picking up the wrong tool or interacting with things incorrectly, I know it seems a bit obvious, but some of the most basic reasons why that is the case is simply the description or even the tool name could be improved upon, essentially make it a bit more verbose and more specific to what it's trying to achieve. But with these tools, you turn to internal ones. So I set up a kind of essentially a quick wrapper of CAT as a service to kind of improve kind of basic talk it through. But when we start creating custom agents, we can restrict agents to utilize certain tools as well. On the bottom left, you've got a little snippet from VS Code. And this is essentially what the basic wrapper is, basic template, boilerplate code that gets created when you, well, boilerplates rather, created when you create a new agent. Obviously, you've got options for name, description, argument hints, and a bit of kind of context. These things need to go fleshed out, start thinking about the kind of system prompts that James mentioned earlier. So these things are going to go in and flesh out and tell it kind of what it is that you're doing, what is the purpose, the context, the output formats, etc. And on the top right, we see a bit more of an inclusion of that. So we've got a bit more of a detailed description. The actual prompt itself is cut off, it's quite long, but we'll go in and say what it is that you're doing, what kind of options what do you serve, what formats you deliver it in. And we start going into the introduction of handoffs. So we could be able to go in and hand off from one agent to another based upon certain conditions. And this could be to say, create a meme or kind of in this example, but that in a kind of more testing world could be something like going creates kind of reference test data or interacts with kind of your API, basically certain test APIs to go and understand whether tests are successful or not. But what we're going to emphasize here is the usage of personas, descriptive, and kind of output formats that are all referenced in those custom agents. So a bit more kind of tooling tips. So definitely use the guidance, the prompting guidance mentioned before. It is all relevant. You may find that as you start kind of interacting with more MCPs and tool calling, you'll start adding it, giving it loads and loads of tools. I think there are limits depending on which provider you're using. So I think OpenAI is like 80 plus tools that are allowed to be used. But what you find is that the more tools that you have, the more kind of exposure you have in terms of which tool to go in and use. So we do recommend restricting the number of tools that you have available to it and trying to leverage handoffs, essentially agents that interact with certain sets of tools. But that's what we found that increases its overall kind of basically improves determinism aspect, basically reducing hallucinations by leveraging more tools, but also a bit more kind of signal feedback. But kind of key takeaway there is kind of the output degrades too many tools. So you'll find that a bit of an easy tip is just to reduce the number of tools that you have. And then if you have any custom or internal MCPs that you have within your organization, one thing we do recommend is essentially providing feedback on how you utilize it and interact with it, because the person who's maybe maintaining it may not be aware of your kind of specific use case. Again, it seems a bit obvious, but it's something that we're noticing kind of within organizations that they're just not providing that feedback to say, when I use this tool, it's either giving me the wrong output or it's not finding the interaction correctly. And that can be fixed by just changing the description or even the kind of the tool name. In addition to that, you can also make improvements around kind of error handling. So when the tool, say, fails for a certain condition, even just saying like, if you're doing this condition, use this tool instead, that goes a long way in assisting the LLM to go in and understand what it needs to do, what it needs to do next, essentially, especially when we start getting it to call upon itself and a bit of a feedback loop for it to go in and plan what it needs to do next. Then we start thinking about semi-autonomous testing agents. We're not going to go into this one too much detail in this webinar. That'll be a future one. But as we start having more agents, especially ones that can hand off, we can start thinking about how we can make it a bit more autonomous. And again, we're going to be leveraging or recommending to leverage personas. So we can start thinking about what can we do in terms of getting like a first first attempt in terms of getting some test case generated. So we may go in and see a Jira ticket being created, and we get that kind of picked up automatically by an agent that goes in and kind of runs off a webhook. They'll go in and try to understand what the requirements are, try to find the context to that. The context ideally wants to be retrieved from kind of a RAG store or a vector database or similar, or can utilize kind of its tools to interact and search with the rest of Jira product or just rest of test cases that it may have access to. You'll then go in and understand and basically kind of build out a high-level view of tests from its persona perspective, and they can then pass it on to another agent who can then go in and flesh it out, basically making more like test cases with more different scenarios, with different hats on, thinking about the performance aspects, thinking about the kind of automation aspect, thinking about the accessibility aspect, through a series of test cases, and then goes in and passes it on to another agent that will go in and try to review them, essentially kind of red team it, essentially. So we start getting a bit more of a cyclical loop to the point where it goes back to kind of say the BA hat for it to go in and review the test cases generated or kind of the approach or the plan being produced. So we start trying to get it to call upon each other. Obviously, the tokens go basically it's like a slot machine. It just fires through the roof, but it does go in and starts trying to kind of do that heavy lifting for us. That when we go in and review it, a lot of kind of the bulk of content has been completed already. But what I wanted to do is go a bit of a kind of test case generation, a bit of an evaluation piece, evaluation kind of interest piece. And I think there's a kind of question in the chat as well around kind of how do we evaluate essentially, and how do we kind of ensure that things are working correctly to kind of reduce hallucination. So we've gone over kind of a few different ways of prompting. So we've got a prompting, just the basics. Let's go in and send a prompt off. And then obviously that could be on Gemini or ChatGPT or wherever. And then we start thinking about gems. So give it more knowledge and give it more kind of awareness. And then we've got options where like in project AI, so this may be the kind of the actual code base of the application, saying it to produce test cases based upon what it knows. And similarly, we can then crawl a website through Playwright MCP and then generate test cases that way. But then how do we kind of verify it? So how do we know what's kind of going on? What's our coverage looking like? Do we actually prove out, interact the field, test a certain state condition? Well, this is where things get a little bit more complicated because we can go in and prove out what interactions it did. So I've got a little image on the right-hand side to go in and kind of indicate a bit of kind of a graph-based view with nodes that are connected to each other. And with that in mind, we start evaluating what's the coverage looking like. And it gives us a kind of nice sort of visual view to see like where are the gaps. What I'm going to do is just go into here. So here we've got a kind of demo website, and this essentially we've got an automation arena that we use internally. It's very simple, but it has kind of a few different pages. So the idea is you go in, start, you go through your journeys, and you basically click on a few different options, and it's trying to go in and prove out the different values it has until it gets completed. And I'll do that for all these values, and essentially go back to go in and say what's been completed or not. This is like a bit of a test website that we have. And what essentially I've told to do is through Playwright, I've said go in, interact with it, and basically solve it. I've been really vague, and somehow on the first prompt, it managed to actually go through and complete the entire automation arena. So in that case, that's been kind of went through. And what I did kind of back of that is that's kind of Playwright crawled. And then I told it to go in and create a series of MD files off the back of that. Essentially go in and say, based upon what you've crawled, document every single page that you interacted with. And now what I want to do is basically generate test cases off the back of that. And of course, in this case, what we can see here is I only covered 11 out of 17 pages. So then it goes into why is that the case? And it goes into the case because I said I wasn't specific enough. I didn't tell it which pages to go for. I just said, go on this page and explore. Now you think about a traditional spider, kind of web crawler spider, it'll go through and see every link, and then it'll make sure that every single link or URL is hit, or every single interaction is pressed to see if it can go into a new state. But on the Playwright side, it doesn't know what it doesn't know, and it's going through and just basically going and stumbling along. If I had told it to interact with certain pages, then it wouldn't have had this issue. So then it goes into, we start trying to give it a knowledge, some form of knowledge. So that can be like a vector store to go in and give it kind of that data to go in and retrieve. So it says, I access this page, I've checked X or Y pages, and then when it does a tool call next about what pages to go on to next, it'll know what's missing or what's kind of on the search bar. The in project, in this case, this is the one that was actually the actual code base of the actual demo websites. Fortunately, when generating the test cases, it found all the pages, which would be a bit concerning if it didn't. But the way it kind of did that was by telling it to essentially look at all your HTML files, your component files to identify them. What I then did off the back of this, so for the in project, I produced a series of requirements off that, converting kind of code into MD files, and then passed that over to kind of a BA gem, to the one that we saw previously. And what was interesting is that in the prompt that was used, it didn't generate test cases for all the pages, which then goes into, we have to be specific. Let's tell it, go in and test X pages and Y pages, because you can't just say, test everything, because it's going to miss something. We need to go in and understand that, which is a great reason why we try to use, especially more now, it's kind of some model-based testing techniques to essentially graph out what's been covered and what hasn't been. And it's a great way for us to go in and essentially find out kind of gaps for certain pages, certain flows of one or another. The Gemini Gem tester, so essentially what this one did was received all the MD files produced by the playwright crawls and then tried to produce it. Fortunately, in this case, it produced the same number of pages, of test cases of those pages. So it kind of goes in and reference, at least the prompt in that case was good. But what we can probably see as a takeaway here is the prompting can only go so far. We have to go in and give that kind of extra reasoning, extra insights to kind of get the value out of it. So I'm going to go jump in back in. So that's a bit of an interest piece about kind of evaluating sort of different ways of prompting very quickly, just mindful of time as well. Then I'm going to talk about risk and dangers. So this is always something that we have to be very mindful of, especially when we start interacting with MCPs, things that were downloaded online, and just kind of hoping it all works. So we kind of brought it out, kind of the key ones here. I kind of whizzed through them, kind of conscious we're all kind of done this one to death almost. So black box AI, ultimately, we don't know what's going on. So we put in an input and receive an output, and we try our best to reduce hallucination. And a great way to do it is through kind of MCP and tool calling and just making kind of decisions or kind of interactions as non-systemic as possible. But we need to be mindful that reward hacking is a thing, as an example. Explainability, this is a bit of an issue. It kind of leads into nicely with accountability of kind of who is ultimately responsible. If it goes in, generates test cases, and it's missed some stuff, how did it miss it? And a nice way to do this is kind of getting those agentic flows, getting it to produce a plan. We can understand that plan. However, there's always an issue where the plan could have been hallucinated as well. So we have to be mindful of how is it interacting with, how it's going to kind of basically go through its echo chamber to go in and produce that overall kind of output. But certainly something that we can do, or certainly something that we can manage by breaking it out into checkpoints, utilizing kind of MCPs heavily, where it's a bit more deterministic in terms of its output, unless it's calling, of course, another LLM and to reduce that. And then data protection, again, it's kind of conscious of time, but just very much, we always have to be careful of what we input and where it's going, especially for MCPs, which is the reason why we're seeing organizations now kind of leverage kind of internal marketplaces for the MCP aspect, so they can have approved MCPs that they're comfortable with using, and not just basically any MCP off the shelf that someone's kind of injected some kind of malicious code in there, similar to what we've seen with some other VS Code extensions. But we might also be mindful of things that we think are safe. So an example that I think people might have been caught out with in the past is kind of Google AI Studio, kind of the free tier. So one thing that we find quite surprising is that in that free tier, I mean, ultimately it's free. We are the product in that case. When you use kind of any unpaid services in the kind of terms, in the Gemini API terms, you submit kind of basically anything content that you submit can be used to improve and develop your products, including human review, which is obviously an angle where even if you're paying for the Google Gemini Workspace products, they have the AI layer, even when using kind of that free tier, kind of not quite attached to it, but it's still kind of Google products, that content, whatever you use, is being sent off potentially for kind of training purposes. So do watch out, do be mindful of where your data is going. And of course, be mindful of kind of PI, confidential information, but you can see kind of trim that out, have it kind of staged where you have LM specifically to kind of strip out or replace kind of PI related data, or essentially just flag it. Again, recommending kind of that chain of 4 elements or tool calling. Again, bit of time constraints, so we don't have opportunities to ask some questions. So I'll hand over back to yourself. Oh, correction. So some key takeaways from the presentation. So keep it simple, keep it specific, good stuff in, good stuff out. But while be mindful of that, do try to provide it as much context as possible. It doesn't know what it doesn't know. And if you don't be specific in terms of what the persona is or where you're trying to reference in terms of what the application is, it will go in and get the data from, as James mentioned, from the internet, essentially, some random location where it thinks a promotion is related to kind of your specific use case. So we need to find a way to kind of provide that context, make it more relevant to the application under test or system under test, so that we get a more meaningful output out. And then consider system level prompting for standardization at an application level. So start thinking about gems, for example, things that we reuse and shared internally within the team. Sorry, okay. So now I'll kind of pass it back over to yourself, Stuart.
Thanks, George. That was great, guys. So so much information shared in throughout that. Thank you so much. We've got a couple of questions. We've got time just for a couple of questions, and I see, James, you've answered one of them in the chat already, so I won't bring that one up. Um, we've got one from Ashwin. So what's the best way to evaluate prompt quality when outputs are probabilistic and vary each time, as each persona may generate different output? And maybe that goes into what you were showing, James, around the validation prompt that you've got in there, but I don't know whether you guys can sort of answer that one a bit more.
Yeah, so there are frameworks out there to help you do that. I think there's also another question. Um, yeah, so basically, there. I mean, I don't know if anyone's heard of DSPy, but that's a very well used framework that will allow you to basically evaluate prompts and kind of look for the reasoning values, etc., for your prompts. It will almost allow you to write your prompts in a more code-like fashion, and it's a really good way of creating structured prompts that also have a better chance of being deterministic. So yeah, so if you're interested in learning more, I think it's dspy.ai, I think is the website. Um, yeah, dspy.ai, and yeah, go on there, have a look. You could there's a learning page on there where you can have a look at the documentation, and it's a good place to get started with that kind of more scalable prompting development.
Perfect. And Matteo, thank you for just drop that into the chat as well. So he's obviously on that one. So brilliant. Hopefully that answers your question, Ashwin. We've got another one from Nagendra. And this is actually an interesting one. It's more around how do you know where to stop in the level of detail to provide when you're prompting? So obviously we've talked about more detail is better, but when do you know when enough is enough? Or do you?
I think you actually weirdly I've experienced this myself where you actually start to see hallucinations because you're trying to focus it too much into one or two things, and you can actually constrain it too much by providing almost too much in the prompt. I do think there is no kind of I think the more sort of important context you can give, and that could be files, it could be relevant. I mean, if you're using something like Gemini, it's really good to provide things like architectural diagrams and help it to understand the system architecture as a whole. But I think there sometimes you can give it too many instructions to the point where you're actually stifling it a bit, and you'll start to see the quality of your outputs degrade slightly. So and I think you have to also judge it yourself. If you're doing a simple task, sometimes a small prompt is fine. Sometimes a small prompt is all you need to get yourself going, and then you can have that sort of multi-shot prompting where you start providing more detail and more context as you go, and you start to iterate, and you'll build up. You'll give the LLM time to build up context throughout those multiple prompts. So if you're doing something that is like a workflow based system where there's an automated AI step where it's going to do some reasoning or something, then that should be a very specific prompt, and that probably needs to be very well engineered. So if you're just asking it something yourself, and you just want a bit of information back, or you want some, you're for example working on a project and you want to start building an API, you need to give it enough to work with to get started. For example, the technology you want to use, are you going to use a framework? Are there specific outputs you need? All of that stuff's really important. You could go down to the level of giving it the exact error messages you want to, or you could let it come up with its own ideas and then push another prompt back and say, I want to refine this part. So it really is up to you. But I think there are you have to kind of use a bit your own common sense a bit with it, and don't try and over engineer prompts for really simple tasks.
Nice, makes sense. And then just one last one from Asmita, which I think is quite interesting. Instead of me writing the perfect prompt, can I write a prompt that instructs the AI to interview me so I can generate the perfect prompt for itself?
We all use it in different ways, and I absolutely. And a nice other way to get it to extract information is obviously talking through it. So it might, who knows, pick up things that you would have forgotten to write out, and absolutely. But then you give it that persona, you tell it kind of that instruction, say interview me, and your intent, your goal and objectives are X, and then you go in, do that interview process, and then afterwards you can go in and say how you want the output to be produced. So then goes into the kind of prompting options.
Yeah, of course you can. You could provide a structure that you expect a prompt to be, and then you could create a prompt generator that uses AI to actually generate additional prompts for you. And you can say, I want a prompt for a software engineering project. I want to build an API, and it would send you back a format with maybe some boxes to fill in with specifics, something like that. Of course you can of course get it to generate things for you. The key thing is knowing yourself what you want in the first place and knowing how to get those steps down in order to get the best outputs.
Nice, brilliant. That's all we've got time for. So thank you again, guys. That was really, really good. Hopefully, everybody that's joined today has learned something new. And we will obviously share the recording around as well, so you can rewatch. I know there's a couple of questions there about the slides being shared. They will also be shared as well. So you'll have all that content to review and go after. And if you are on your own AI journey within your organizations and you're looking for some support or direction, then obviously reach out to us. And if you're interested in any of the services that we can offer to help enable or accelerate your implementation, then yeah, just get in touch and we can have a chat. So, but that's it, I think, for this webinar. Thanks again. Thank you to everybody that's attended, and yeah, we'll see you next time. Thank you. Bye-bye.
Cheers, everyone.
Thanks. Bye.